Okay, welcome back. So just now we went through what does sigma notation means, and now I'm going to go through some useful formulas when it comes to sigma notation. So first of all, let us take a look at this. I want to sum up r from r equals to 1 to r equals to n. Alright, so when you write out a series, you will get something like this, right? 1 plus 2 plus 3 all the way until n. Okay, remember 1 is the first term and you store the last term, in this case is n. Now n can be any numbers. It can be 5, it can be 6, it can be 1000, 1 million, right? So it's a variable under here, right, the n. Okay, and the formula for this sum is given by n over 2 open bracket n plus 1. Okay, and of course if you learn your AP and GP, alright, you will realize that this is actually a sum of AP, right? 1 plus 2 plus 3 all the way until n. The common difference is 1. Can you see? Right? 1 plus 1 is 2, 2 plus 1 is 3. The common difference is 1. And you can recall what is the sum of AP formula? Alright, is Sn equals to n over 2 a plus l. Correct? N stands for the number of terms, a stands for the first term, and l stands for the last term. Okay? In this case, the number of terms is n minus 1 plus 1. If you can recall from the previous part, right? That's the number of terms. So in total there are n terms. Right? So in this case, n is still n. Okay, the first term is 1, right? So 1 is your a over here. Can you see? The 1 is the a is 1, right? And the last term is n, right? So it's n plus 1. Okay? And so with this formula in mind, we are able to calculate the sum, right? From, let's say you want to sum up r from r equals to 1 to, oops. Alright, you want to sum up r from r equals to 1, okay, to r equals to 10, right? So instead of writing out a series 1 plus 2 plus 3 all the way until 10, this is what you do, right? You simply sub 10 into the n over here. Okay, you simply just substitute this 10 into the n over here, right? So you get 10 over 2 open bracket 10 plus 1. Okay, and so if we simplify this, 10 over 2 is 5, right? 5 times 11, so you get a total of 55. Okay, so this is the first formula that is very useful, and of course there are a few more. Alright, this is the first one. Okay, the second one is if you want to sum up r square, right? Okay, that means you get 1 square plus 2 square plus 3 square until n square. Okay, and the formula is given by n over 6 n plus 1 2n plus 1, right? Right, these are all direct formula. Okay, and the third one, alright, if you want to sum up r cube, alright, that means it's 1 cube plus 2 cube plus all the way until n cube. And the formula is quite unique, right? The quite special, right? This formula is just n over 2 n plus 1, then you square the whole thing, right? Okay, if you notice, this is basically the square of the first one, right? Basically you just take the first formula, then you apply a square to the whole thing, right? And this is the summation of r cube. Okay, next part, some other things to take note is what happens if the first term is not 1, right? I want to start from 0. Okay, does my formula change in this case? Okay, the answer is no, right? Okay, why it doesn't change? Because when r equals to 0, you get 0, right? Then you plus 1 plus 2 until n, right? Okay, if a sum plus 0, 0 is nothing, right? So it doesn't affect the sum at all. So the formula is still the same, right? It's still n over 2 n plus 1. Okay, so same thing for summation of r square and summation of r cube. It doesn't matter if the first term is a 1 or 0. The formula doesn't change, or it remains the same. Okay, however, this doesn't apply to everything. So for example, if you want to sum up a constant, okay, so we want to sum up a constant, but I don't want to start from 1. I want it to start from 0. Okay, in this case, will the answer change? The answer is yes. Okay, why? Because when you sum up the a, how many a's will you get in total now when you start from 0? Okay, you'll get a total of n plus 1 is. Okay, once again, how do I get n plus 1? You take the last term, minus away the first term, then you plus 1 behind. Alright, so you get a total of n plus 1 term. And so the answer will be n plus 1 times 8. Understand? Alright, compared to if I start from 1, right? If I start from 1, if I want to sum up a constant a, right, the answer is a times n, right? Remember, you just take a times number of terms. In this case, there are n terms. But when you start from 0, now there are n plus 1 terms. Alright, and so if I want to make it start from 0, right, you must be very, very careful. If it's error, right, it doesn't matter. Alright, the formula remains the same. But if you want to sum up a constant, and the first term is a 0 instead of a 1, right, the answer will change. Okay, and so let us take a look at some other useful formula. Okay, let's take a look at this, right? I want to sum up from 1 to n. Okay, I want to sum up this a to the power r. Okay, and so let's observe the pattern first. When you put in 1, you get a to the power 1. You put in 2, you get a to the power 2. Alright, all the way until you put in n, you get a to the power n, right? Okay, of course, if you notice, this is actually a sum of a GP, right? Can you see? A geometric progression. And the common ratio is a, right? A times a is a square times a is a cubed, all the way until a to the power n. If you can recall from the previous topic, alright, what is the sum of a geometric progression? The formula is a bracket r to the power n minus 1 over r minus 1, alright? Okay, so in this case, a is the first term. In this case, is still a. Alright, but what's the common ratio in this example? Right? The common ratio is again a, right? Can you see? Because a times a is a squared, right? Okay, so if you apply the formula, you will get a bracket a to the power of n is the number of terms, right? In this case is n minus 1 plus 1, so it's still n. Okay, then you minus 1 over a minus 1. Okay, so this is how you apply the sum of GP formula to solve this sort of sigma notation. Okay, let's take a look at another example. So for example, I want to sum up from r equals to 3, right, to let's say example n, right, and I want to sum up 2 to the power r. Okay, a simple example. Okay, so let's do slowly at the start. The first term you put 3 inside, you get 2 to the power 3. Okay, followed by 2 to the power 4, and all the way until 2 to the power n. Okay, in this case, what is the first term? The first term is 2 to the power 3, right? 2 to the power 3 is 8. So the first term is 8. Okay, what is the r? The r is 2, right? Okay, it's 2. And what is the number of terms? You take n minus 3 plus 1. Correct? So n minus 3 plus 1, you will get n. Oops. Okay, you will get n. Whoa. Minus 2, right? Okay, this is the number of terms, right? N minus 3 plus 1 is n minus 2. Okay, then you take minus 1 over 2 minus 1. Okay, and of course 2 minus 1 is still 1, so the answer is 8 bracket 2 to the power n minus 2 minus 1. Understand? Okay, let's take a look at the last example. Okay, now I want to sum up from I equals to 1 to infinity, right? Okay, for example, I want to sum up half to power r. Okay, once again, if you express this thing out, okay, you will get half to the power 1 plus half to the power 2 all the way until infinite, right? Okay, remember, this is a sum to infinity, right? Because it doesn't have an end, right? It adds all the way to infinity. And of course, you can recall under the previous topic, this is actually the sum to infinity of a GP, right? And the formula is given by a over 1 minus r. Okay, in this case, your a is your first term, right? A is half, and the r is still half, right? Okay, so you get half divided by 1 minus half is half. Half divided by half is 1, right? So the sum of infinity is 1. Okay, so once again take note, this sum of infinity only exists when mod r is lesser than 1, right? You can recall from the previous topic. If not, this sum of infinity doesn't exist. But in this case, the r is half, right? You modulus half is still half. Half is lesser than 1. In this case, that's why in this case, the sum of infinity actually exists. Okay?